Hello everyone and welcome to today's paper walkthrough guide from Pure Mathematics 1, June 2019. So let's get started with the first question. We're given a function fx equals 3x cubed plus 2ax squared minus 4x plus 5. Given that x plus 3 is a factor of fx, find the value of the constant a. So this is quite straightforward. All we need to do is that since x plus 3 is given to be a factor, we can simply substitute in x equal minus 3, the solution of x, into our function, and that should be for fx is equal to 0. So that means f minus 3 is equal to 0. So let's put in minus 3 here into our equation. 3 minus 3 cubed plus 2a minus 3 square minus 4 times minus 3 plus 5a is equal to 0. So then this simplified to minus 81 plus 18a plus 12 plus 5a is equal to 0. So if you rearrange this, you should get the expression 23a is equal to 69. So once you divide both sides by 23, you will get a is equal to 3. So this is how you answer the first question. Moving on to the second question. So here we have a plot that shows part of the curve with the equation y equal cos x. And x here is measured in radians. Using so there's another diagram here on the opposite page. So over here. So we are asked to use the diagram 1 to show why the equation cos x minus 2x minus half is equal to 0 has only one real. Okay, so you can see this equation, it's basically they've equated, or this is the intersection of the curve cos x and 2x plus half, y equal to x plus half. The intersection of these two curves gives this equation. So we can now plot y is equal to 2x plus half on this question. So remember, y equals 2x plus half is the curve we're sketching. So essentially, it should be a curve. So from this, we know that y-intercept is half, and no, this is supposed to be 1. So therefore, around here, and with that gradient, it would be something like this. And so you can see here, there's only going to be one intersection. Therefore, there's only one real root for the intersection of y equal 2x plus half and y equal cos x. On to the second part of this question. Given that the root of the equation is alpha and that alpha is small, use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. All right, so in this case, we need to make use of the small angle approximation for cos x, which is that for small angles, cos x can be approximated to 1 minus 1 over, or rather 1 minus x squared over 2. So this is the small angle approximation for cos x. So instead of cos x, we can write 1 minus x squared over 2 to get 1 minus x squared over 2 minus 2x minus half is equal to 0. So if we now multiply the equation throughout by 2, we'll end up getting 2 minus x squared minus 4x minus 1 is equal to 0. So this leads us to the quadratic equation x squared plus 4x minus 1 is equal to 0, which you can now solve using a calculator, and you should find the two solutions to be 0.236. You can ignore negative value, and therefore this will be your final answer. So the mark distribution for this particular question is you get 1 mark for the correct use of the small angle approximation. You get 1 mark for approximating, use application of the small angle approximation here, and then solving the quadratic equation, and then getting your final answer gives you 1. As for the previous part, in this part here, you get 1 mark for the correct diagram here of the two intersecting lines, and showing that because of the one intersection, this proves that there's only one real root. That gives you the second. So the marks distribution for this question is using that f minus 3 is equal to 0 gives you 1 mark. And then arriving at the correct substitution to get 23a equals 69 gives you 1 mark. And finally, a equals 3 gives you the final. Now let's move on to question 3 here. So we are given the function y equals 5x squared plus 10x over x plus 1 square. And we are asked to show that dy over dx can be written in the form a over x plus 1 to the power n, where a and n are constants to be found. So for this, we can make use of the quotient rule, which is dy over dx is equal to v is equal to v du over dx minus u dv over dx over v squared. Right. So this is the quotient rule. So we need to now substitute in our terms. Now, before that, we need to separate the terms here. So u is going to be 5x squared plus 10x, and v is going to be x plus 1 squared. So that means that du over dx would be equal to 10x plus 10, and dv over dx would be equal to 2x plus 1. Right, so now I can substitute this into my formula over here. And so dy over dx is going to be equal to v is x plus 1 square multiplied by 10x plus 10, which is du over dx, minus 5x square plus 10x u, and then dv over dx is 2x plus 1. And this whole thing, it's going to be over v square, which is x plus 1 to the power 4. All right. Now it's time to simplify this equation. So here I can actually simplify this part, where I can take out, first I'm going to expand this, by the way. This before expansion, I need to take out the terms here, x plus 1 square, 10x plus 10 minus, so here I can take out the terms 5x, right? And then what I'll be left with inside are x plus 2. And so after this, x plus 2, we can simplify this to be 2x plus 1 whole thing over x plus 1 to the power 4. Okay, so now we need to simplify once again. Here you can see that x plus 1 actually, so there's a small error here. It's supposed to be 2x plus 1 rather. Here it should be 2x plus 1 right? So because of this, you can actually simplify this. So you can get rid of a couple of the terms here. Let me just simplify this once again. Now that we've arrived at this point, we found our variables for u, v, and as well as the derivatives. We can now apply it back into our coefficient rule. So dy over dx is equal to v here is x plus 1 square times 5x, or rather, sorry, this should be 10x plus 10 minus u is 5x squared plus 10x. dv over dx is equal to 2x plus 1. And this whole thing should be divided by v squared, which is x plus 1 to the power 4. So you might notice that x plus 1 occurs in all three terms of this expression. So you can actually get rid of it. This becomes 3. So you can simplify. So now you can expand the numerator here to get 10x squared plus 10x plus 10x plus 10 minus over here we'll have 10x squared minus 20x. Whole thing over x plus 1 to the power 3. So then 10x squared minus 10x squared cancel out. 10x, 10x, 20x minus 20x also cancel out. So therefore, your final answer for dy over dx is equal to 10 over x plus 1 to the power 3. So from this, you will get a is equal to 10 and n is equal to 3. That is how you answer this question. So for this, the mark distribution, correct application of the coefficient rule gets you 1 mark. Then substituting in your correct values, another mark. Finally, making sure to eliminate the terms in order to simplify gets you another mark. And your final answer of 10 over x plus 1 cube gets you the final. Right, on to part B of this question. Hence, deduce the range of values for x for which dy over dx is less than 0. So if you look at this function here, you can see that in order for 10 here, now obviously, denominator here is a cube number. So that means if we have a negative number in our denominator, our dy over dx will be less than 1. Therefore, the condition for which our denominator here is negative would be x less than minus 1. So if x becomes less than minus 1, this becomes negative. Therefore, dy over dx is negative as well. So you can write this down over here, part B. For x less than minus 1, dy over dx is less than 0. And you can mention this is because n is odd. So this is how you score the 1 mark for this part. Right, moving on to question 4. So question 4 here, we have a fraction here, 1 over square root 4 minus x. And we're asked to find the first 3 terms in the expansion of this binomial term. Right. So here we need to make use of the binomial expansion form. But before that, we need to first get our expression into the correct binomial term. So that means 1 over square root 4 minus x. You can rewrite this as 4 minus x to the power negative half. And then if you take 4 minus half out as well, what's going to remain inside the brackets are 1 minus x over 4 to the power minus half. So it's important here And when you take the 4 out, its exponent here is also minus half. So this here is of the form 1 plus ax to the power n, right? And we know the expansion for this particular binomial term. So therefore, we can apply that 1 minus x over 4 minus half, right? So this is going to be our first term here, 1 plus a here, which is minus 1 over, sorry, this is n here, which is minus half, times a or x term minus x over 4 plus, now the third term is going to be minus half times n minus 1 is going to be minus 3 over 2, whole thing over 2 multiplied by, this is going to be minus x over 4 square. So once you simplify this, you should get 1 plus x over 8 plus 3x square over 128. And now remember, there's also this 4 to the power minus half term, which is simply going to be half because 1 over square root 4 is half. So you need to multiply your expression or these terms here by half to get your final answer. You can say, therefore, 1 over square root 4 minus x, the first three terms will be equal to half plus x over 16 plus 3x square over 256. That's the answer for the first part. So the marks distribution, once again, making sure that your expression is in the correct binomial form gives you 1 mark. Using the correct form, once again, another mark. And then the correct expansion with the substitution gives you another mark. And your final answer gives you the final mark. All right, on to part B of this question. So here, the expansion can be used to find the approximation to square root 2. Possible values of x that could be substituted in this expansion are x equal minus 14, x equal 2, and x equal minus half. So you can see each of these substitutions here. And in part B, without evaluating your expansion, state giving a reason which of the three values of x should not be used. Okay, quite straightforward, this one. We know that obviously the modulus of x can't be greater than 4, but since x, so in part B, that was x equal 14, right? So for x equal minus 14, the modulus of x is going to be greater than 4. Therefore, the expansion is not valid. All right, that's part I. And then for part 2, so state giving a reason which of the three values of x would lead to the most accurate approximation of root 2. Oh, so for this one, you need to look for the smallest value of x, or the one that's closest to 0. And in that case, that would be x equal minus half. So part 2 here, x equal minus half. And you can state that because it is closest to 0. So for each of them, you get 1. So let's go on to question 5 here. So we're given a function fx is equal to x squared plus 4x plus 9. And we're supposed to write fx in the form ax plus b whole thing square plus c, where a, b, and c are integers to be found. So in this question, we have the function fx is equal to 2x squared plus 4x plus 9. And in part A, we are supposed to write it in the form ax plus b squared plus c. So in the complete square form. So for this, we need to make use of the complete square method. So fx is equal to 2x squared plus 4x plus 9. We need to look at b here in our term, which is 4. So b over 2 is equal to 2. So we need to add b over 2 here to get our form. Now, before that, we also need to make sure we can factor out the common factor 2 here. So this will give us 2x squared plus 2x plus 9, right? So then, yeah, now b has changed to 2 actually. So you would be b over 2 is equal to 1. So you add 1 here and you minus 1 as well. So should be like this, 2x squared plus 2x plus 1 minus 1 plus 9. So this minus 1, you can multiply by 2 and take outside the bracket. And then this part you can actually factorize as a perfect square to get 2x plus 1 square minus 2 plus 9. And this will give you your final answer, 2x plus 1 square plus 7. So the marks distribution for this question is making use of the complete square method gives you 1 mark. Then getting your x or vertex value correct gives you 1 mark. And then finally, the full correct answer gives you the 3rd mark. So on to part B. Sketch the curve with the equation y equal fx showing any points of intersection with the coordinate axis and the coordinates of any turning points. So we can make use of this form here, the complete square form, in order to help with the help with drawing or sketching our graph here. So we know the minimum point is going to be given by the coordinates 1 and 7 here. And we also know the intercept would be plus 9. Right, so we can then sketch it over here. This is my y-axis. This is my x-axis. So remember, the y-intercept is at 0, 9. Let's just say over here, 9. And our minimum point is at minus 1, 7. So minus 1, 7 is approximately around here. So then you can draw the curve to look like this. And once again, remember this point here, it's minus 1, 7, your minimum point. And this is the sketch of the graph. So if you get the correct U shape here for your function, you get 1 mark, because remember it's a quadratic function. That's why we have a U shape. That's 1 mark. And then the y-intercept here gives you another 1 mark. And finally, the minimum point gives you the 3rd mark. Moving on to part C here, describe fully the transformation that maps the curve with the equation y equal fx onto the curve with the equation y equal gx, where gx is given as this function over here. Right, so for this one, we need to first substitute here into our function. So you can see x minus 2 is what they've used in substitution. So we can put that into our function here and see what we get, our original function, right? So I'll do it over here, part B, so rather part C. So remember, this is the function we have, 2x minus 2 square plus 4x minus 2 plus 9. So I put x minus 2 instead of x into our original function. So now if I expand this, now obviously I can leave this the same because that's what they've given here in the function as well, x minus 2. So that remains the same. So then 2x minus 2 square, this becomes plus 4x minus 8 plus 9. Right, so then 2x minus 2 square plus 4x, this becomes plus 1. And now if you compare this with the function given over here, you can see here we have minus 3 and here we have plus 1. So then that means we need another translation of minus 4 in the y-axis, minus 4 here. Then this becomes the same as the one given in the expression, 2x minus 2 square plus 4x minus 3. So then we can say translates 2 minus 4. This is going to be your answer, right? So it translates 2 units in the x-axis and then negative 4 units in the y-axis. So if you get this translation correctly, you get 1 mark. And remember, you need to mention that it is translated, which will give you the second mark. Then in part 2 here, we are asked to find the range of the function hx is equal to 21 over 2x squared plus 4x plus 9. So this is basically fx here in the denominator. So what we need to do is we can write the complete square form here in our hx. So right over here. So instead, hx is equal to 21 over 2x plus 1 square plus 7. Right. So now in order to find the minimum value, we need to look at our x here. So you can see that when x here or this value grows larger, our hx becomes smaller. Now in order to find the maximum value, we need to see what's the lowest this value can get. And since this is square, that means that any number that's going to be greater than 0 or less than 0 will be positive. Therefore, if we put here -1, this becomes 0, right? So when x is equal to -1 becomes 0, and therefore this becomes 21 over 7. So therefore, approximately we can say 3, and then the range would therefore be 0 to hx greater than or equal to 3. So the maximum value will be given as 3. So in this case, if you manage to mention the correct substitution here, the -1 to get 21 over 7, you get 1 mark. And then finally, the correct range for the x values gives you the final mark. So that's going to be the end of question 5. Now let's move on to question 6. So in question 6 here, we are asked to solve for theta in between -180 and 180, the equation 5 sine 2 theta is equal to 9 tan theta, giving our answer to 1 decimal place. So for this, firstly, we need to make use of the double angle formula here to replace the sine 2 theta. So this would be written as 5 sine, so let me write the original expression, 5 sine 2 theta is equal to 9 tan theta. So instead of sine 2 theta, we can write 5 2 sine theta cos theta. And then over here on the right hand side, instead of tan theta, I'm going to write 9 sine theta over cos theta. So you can see sine theta appears on both sides of the equation, which means you can cancel it out. And if I then rearrange the expression, I will get 10 cos square theta is equal to 9. Right, so now I can solve for cos theta here. So cos theta would be equal to square root of 9 over 10. Remember, this is plus or minus. So plus or minus square root of 9 over 10. And therefore, theta will be cos inverse of plus or minus square root 9 over 10. So if you type this in your calculator, this should give you a couple of answers here. So theta will either be plus or minus 18.4 degrees. And your other pair of solutions will be plus or minus 161.6 degrees. And remember, since this is the cos function here, we need to also take into account theta, which is at 0. So theta, 0, and plus or minus 180 are the other pair of solutions. So there's a total of 7 solutions for this question. So the marks distribution for this particular question is that using of the double angle formula here gives you 1 mark, as well as using the correct application of other formula gives another mark. And then finally, getting an equation in terms of either cos or you can use sine as well gives you another mark. and then using it to solve for cos inverse, another mark, and then two of your solutions here, another mark, and then finally 1 mark for the final solution. So a total of 6 marks for this particular question. Right, so in part B, we are asked to deduce the smallest positive solution to the equation 5 sine 2x minus 50 uh, x minus 25. So you can see here, we have x minus 25 instead of theta here. So that's the difference. So in order to find the smallest positive solution, let's look at our solutions and see. So from this, you can see in order to get the smallest pair, it would obviously be using this particular value. So if I equate x minus 25, that's the new function you have, is equal to the solution minus 18.4 degrees here. So if I then solve this, if I take this negative 25 to the other side, I will get 25 minus 18.4. This will give me 6.6 degrees. And this will be my smallest positive solution. So one step for correctly equating the solutions, and then one step for the final answer. So that's the end of question 6. So in question 7, a simple model, in a simple model, the value pound V here of a car depends on its age t years. Following information is available for car A here. It says its value when new is 20,000 pounds and its value after 1 year is 16,000. Using an exponential model to form for car A possible equation linking V with t. So for this, remember, a general exponential model would look like A is equal to, or rather, sorry, this should be V here. V is equal to A E K T minus KT rather, because this is a exponential decay, as you can see, right? So for this, we need to now find out what our solutions are. So let's substitute in the given values. So we know that when it's new, it's 20,000 pounds. So 20,000 is equal to A times E. So here T is equal to 0 now. So this gives us 0, which means A is equal to 20,000. So we found our constant A. Now we need to figure out what the value of our constant K is. So for that, I need to make use of the second piece of information here, which is its value after 1 year is 16,000. So this gives me 16,000 is equal to 20,000 e to the power minus K. Right? Because remember, t is equal to 1 now. So if I now solve this, I will get K is equal to negative 0.223. So you can divide both sides by 20,000 and then get the logarithm, and you will get K is equal to negative 0.223. Therefore, the model will be V is equal to 20,000 e to the power minus 0.223 t. This is my final answer. So the marks distribution for this question is using the initially using the correct model gives you 1 mark, and then using the correct substitutions gives you another mark to find each of the constants, and then finally getting the correct model gives you the final mark. Right. So now let's move on to part B here. So in part B, evaluate the reliability of your model in light of this information. So in order to evaluate, so here it says the value of the car A is monitored over 10-year period. Its value after 10 years is 2,000. So we need to now apply this information into our model here and see if it's correct or not. So let's see. So when you substitute in t is equal to 10, we will get V is equal to 20,000 e to the power minus 0.223 times 10. So if you type this in your calculator, you will find V is approximately equal to 2150. And since 2150 is close to £2,000. We can say, therefore, the model is accurate. And so the marks distribution for this question is using of the correct substitution gives you 1 mark, and showing the conclusion here with approximating the answer to 2000 gives you the final mark. And then in the next part here, the following information is available for car B. It has the same value when new as car A. Its value depreciates more slowly than that of car A. Explain how you would adapt the equation found in A so that it could be used to model the value of car B. So here, the important piece of information is its value depreciates more slowly. That means that the value of K here would be less negative. It would still be negative, but the value or the magnitude of it would be less. Therefore, you can mention, this is part C here, make the value of K less negative. So that's your answer part C. If you mention this, you will score the mark for that. So that's the end of question 7. Moving on to question 8. So in question 8 here, we have a function, and the function is given with the equation y is equal to x times x plus 2 times x minus 4. And the region R1 here shown shaded is bounded by the curve and the negative x-axis. So you can see R1. We are asked to show that the exact area of R1 is 20/3. So first of all, we need to figure out what exactly the intervals are. So obviously this passed through the origin, so that's going to be 0. We need to figure out what this coordinate is. So since we are given the equation here, we can already see it's given in factor form. Therefore, this means that the solutions for this particular curve here are x equals 0, x equal uh, x equal -2, and x equal -4. So therefore, we can simply put these values into our, we can use x equal -2 as our intersection point here in order to get the area. So let's do this over here, the integration. So firstly, we need to also expand our equation. Part A here. We have y is equal to x minus or x plus 2, x minus 4. This is the equation which we have. So we need to expand this. So let's first expand the two factors here. You get x square minus 2x, and then we have minus 8. Right, so once you expand this one more time, we will get x cubed minus 2x square minus 8x. Right. So this is what we're supposed to integrate here. So integrate from 0 to -2. Remember, these are the intercepting points for the region R1. So R1 here is equal to integrating from 0 to -2, our function x cubed minus 2x square minus 8x dx. Right. So then if we perform the integration here, we will get x to the power 4/4 minus 2x cubed over 3 minus 4x squared. And remember, you need to apply limits from 0 to -2. So you can see if you apply 0 here, obviously, you will end up getting 0 as the first term. And then the second part here, we have -4 plus 16/3 for the second term here because of this negative sign. And then finally, when you put -2, you get -16. Right, so then you can simplify this and you will find your answer to be 20/3. And that is exactly the same as the one shown here. So the marks distribution for this question is getting the expansion gives you 1 mark. And then applying the limits here correctly gives you another mark. And then also getting the correct integral gets you another mark. And your final answer for the area gets you the final mark. So that's the answer for part A. So in part B of this question, the region R2 is also shown shared in figure 2 here, bounded by the curve, the positive x-axis, with the line with the equation x equal b. So you can see here, its interval is from 0 to b in the x-axis, where b is positive constant and the value of b is 0 in between 0 and 4. Given that the area of R1 is equal to the area of R2, verify that B satisfies the equation given here. Right. So for this, we need to now equate the given area, which we got previously as 20 over 3, and also the integral, the integrated expression with B instead of X. So therefore, that means we have 1 over 4 B to the power 4 minus 2 over 3 B cubed minus 4b squared. This is basically the integral we got, but instead of x, we substituted b, and this is equal to 20 over 3, the area. And so if we now rearrange this expression, getting rid of the fractions, we should get 3b to the power 4 minus 8b cubed minus 48b squared plus 80 is equal to 0. So this is now in standard form here. So once we come to this, now remember we are supposed to factorize this in a way we get this expression, right? So here we know b plus 2 is one of the factors. So we can test this by substituting into our expression this value and seeing what we get, right? So if we put in b is equal to, when b is equal to minus 2, right? That is for this one. So then 3 here we get minus 2 to the power 4 minus 8 to the power minus 2 times 3 minus 48 minus 2 square plus 80 is equal to 0. So this, the values here would be equal to 48 plus 64 minus 192 plus 48. And if you check this, this is going to be equal to 0. So what this means is that b minus 2 is in fact one of the factors for expression. So we can then use that and substitute it into our expression, or we can use rather polynomial long division for b plus 2, and we should obtain this given expression here, which is b plus 2 square 3b square minus 20b plus 20 is equal to 0. So this is the expression. So the marks distribution for this question is getting the correct substitution and equating it to the area gives 1 mark, and then rearranging it to get this expression another mark, and then using a method to find the factors. So either substitution and then using polynomial long division, and finally getting the correct expression gives you the final mark. So that's a total of 4 marks for part B of this question. So then on to part C here. The roots of the equation 3b square minus 20b plus 20 is equals to 0 are 1.225 and 5.442 to 3 decimal places. The value of b is therefore going to be 1.225. That's because remember b lies between 0 and 4. Explain with the aid of the diagram the significance of the root 5.442. So you will see if we sketch a plot of this, or rather we can actually go back to our given plot here. It's simpler. So right from here, you can see that this, we found the value here to be 1.225. So this here is equal to -2. And we found this is 0. And this here was supposed to be minus, sorry, no, rather not minus. This is going to be 1.25. 1.25. And now the question is asking what's the significance of the other root, which is 5.442. Now, obviously, we know this is 4 here, and 5.442 is going to be somewhere around here. That means around here. So this area is encompassed by that 5.442. What this means is that the area above the x-axis, that means R1, and the area encompassed from x equal 4 to 5.442 will be equal to the area under, which is this part over here. That's the significance of this second root here, 5.442. So you can mention that over here. Part C here. Between x equal -2 and x equal 5.442, area under the x-axis is equal to area above the x-axis. This is the conclusion which we can reach from looking at the graph. So making sure you mention the correct coordinates and also the correct conclusion, which is the area under the x-axis is equal to the area above the x-axis, gives you the 2 marks. So that's the end of question 8 there. So now let's move on to question 9. So in question 9, we are given that a is greater than b is greater than 0, and that a and b satisfy the equation log a minus log b is equal to log a minus b. Show that a is equal to b square over b minus 1. So here we need to apply the logarithmic rules here. So for this expression, instead of a minus b, we can write log a minus log b is equal to, this would be log a over b, right? So then obviously log is common throughout the expression, so I can get rid of it. And so a minus b is equal to a over b. If I multiply by b throughout and rearrange to make b square my subject, I'll get b square is equal to ab minus a, right? And if I now factorize a out from this second term here, I will get b minus 1, divide both sides by b minus 1. And so a is equal to b square over b minus 1. This is the answer for part A. So applying the correct logarithmic rule gives you 1 mark. And then obtaining an expression, a linear expression, gives you 1 mark. And then rearranging it to make a the subject gives you the final mark. That's part A. Oh, I forgot 1 mark over here. So then in part B, write down the full restriction on the value of B, and we have to explain the reason for this restriction. Right. So here you can see if B becomes 1, right? If B becomes 1, then our denominator becomes 0. And we know that if we divide anything by 0, it becomes infinite or non-defined. Therefore, we would say one of the restriction is B is not equal to 1, right? Since b square over b minus 1 is not defined for b equals 1. Now that's one restriction. And remember that here it says a is greater than 0, right? A is greater than b and greater than 0. So if a greater than 0, right? And remember b square over b minus 1 is a, so we can then write this as b square b minus 1 greater than 0. And so in order for this to be true, our denominator here, because remember, b square is always going to be positive, the denominator here has to be positive as well. And the condition to satisfy this would be b greater than 1. Because if b less than 1 here, then this would be negative, and this condition would not be satisfied. Therefore, b greater than 1 is our answer. So each of these restrictions will give you 1 mark each. That's the end of question 9. So in question 10 here, we are asked to prove that for all
real numbers of n square plus 2 is not divisible by 4. So for this, we need to show algebraic proof here. So let's say that if n here is equal to certain odd number, n is equal to 2m, even number, n equal to 2m, right? That means that n square plus 2 here would be equal to 4m square plus 2, right? So from observation alone, you can see that this is not divisible by 4. In order for it to be divisible by 4, there has to be multiples of 4 or a factor of 4, but that's not the case. So therefore, not divisible by 4. Now, this is the case for a even number, remember, even. Now, for odd number, right, which is n equals 2m plus 1, if we now once again find n square plus 2 here, we will see that this is going to be equal to 2m plus 1 square plus 2. So by expanding this and factorizing out 4 from the m terms, we get m square plus m plus 3. This is what happens in the expansion. So once again, you can see we don't have a common factor 4 in both the terms. Therefore, not divisible by 4 either. So this is how you prove the statement given here, which is that n square plus 2 is not divisible by 4. So the mark distribution here is showing the two different cases, gives you 1 mark each. And then for each of them, showing that they're not divisible by 4, gives you the fourth mark. So then on to part 2 here. Given x is a real number, the value of modulus 3x minus 28 is greater than or equal to the value of x minus 9. State, giving a reason, if the above statement is always true, sometimes true, or never true. Right. For this, once again, we'll need to make use of some sort of a proof method. So this time, I'm going to use numerical substitution. Right. So let's take, so in the case, if n here, or rather x in this case, so if x here has a value between 9.25 or 9.5, right? That means it's basically going to give us a value for this particular binomial term to be either less than 0.5 or greater than 0.25, right? In those cases, you will see that, for example, when x equal 9.4, right? This is a value that lies between those two values of x that I mentioned. So for this 3x minus 28, if you put in x equal 9.4, you will get 0.2, right? And when you put in x minus 9, 9.4, you will get 0.4. So in this case, you can see that this value actually 0.2 is less than 0.4. So therefore, this is going to be false. And that's for our first case. Now let's pick any other value, right? That means outside of the range that I mentioned, which is x 9.25, x 9.5, right? So in this particular range, right, outside of this range rather, let's say, for example, when x equal 12, if we now substitute in this value, so 3x minus 28 for when x equal 12, we will get 8. And the same thing, x minus 9 here, this gives us 3. So you can see in this case, yes, this 3x minus 28 is in fact larger than x minus 9. Therefore, what we can conclude is that the statement is sometimes true. That's the answer for this question. So the mark distribution here, once again, for analyzing or using a certain numerical proof gives you 1 mark, and then using that to come to the correct conclusion gives you the other mark. So a total of 2 marks for this question. So that's the end of question 10. So in question 11, a competitor is running a 20-kilometer race. She runs each of the first 4 kilometers at a steady pace of 6 minutes per kilometer. After the first 4 kilometers, she begins to slow down. In order to estimate her finish time, the time that she will take to complete each subsequent kilometer is modeled to be 5% greater than the time that she took to complete the previous kilometer. Using this model, show that her time to run the first 6 kilometers is estimated to be 36 minutes and 55 seconds. So for this part, in order to find the total time, we need to calculate. So obviously it says that she's running a 20 kilometer race, and the first 4 kilometers at a steady pace of 6 minutes per kilometer. So 4 times 6 gives us 24 minutes for the first 4 kilometers. So 4 times 6 equals 24 minutes. Now this is for the first 4 kilometers. Now the total would be equal to 24 plus, now after that, the next 2 kilometers that she's going to run, it says that the time taken for each of the subsequent laps is 5% greater. So that means that if she takes 6 minutes for the previous one, it'll be 1.05 greater. Likewise, for the next run, it will be 6 times 1.05 times 1.05. So then you can use this to calculate the value to be 36.915. Obviously, we need to convert this decimal amount into seconds. And if we do so, we will find this is approximately equal to 36 minutes and 55 seconds. That's the answer for part A of this question. So for this, you get 1 mark for getting the total correct here with the initial time taken as well as the subsequent runs. And then the final answer gives you the final mark. Then in part B, we are asked to show that her estimated time in minutes to run the nth kilometer for the 5th to the 20th kilometer is 6 times 1.05 r to the power minus 4. So you can see clearly this is a geometric progression or geometric series where with each successive lap, the runner basically takes 0.05 common ratio greater than the previous lap, or we could say 5% greater time than the previous lap. Therefore, if we do this correctly, so that means the fifth kilometer would be equal to 6 times 1.05. Then we could basically write as 1, right? And then the 6th kilometer would be 6 times 1.05 times 2. 7th one would be 6 times 1.05 times 2, 3. So you can see there's a difference of 4 in their exponent powers from the kilometer that they're in. And therefore, you could say the rth kilometer, or the rth time rather, the rth time is equal to 6 into 1.05 r minus 4. That's the answer. So if you show this proof here, you will get 1 mark. Next, estimate the total time in minutes and seconds she will take to complete the race. So now we need to do it for the entirety of the race. So for this, we obviously need to take the total time. So total time would be equal to, which is the first one is 24 minutes for the first 4 kilometers. We know that already. And to that, we need to now sum all the subsequent runs. The sum of the runs from r equal 5, the 5th lap, to the 20th one, right? And remember, it is given in the formula 6, 1.05 r minus 4. So this is the formula we need. So we need to make use of the sum of a geometric progression formula, which is a r to the power n minus 1 over r minus 1 for this. So we can do this as, so 24 plus, this would be equal to 6.3, 1.05 to the power 16 here. This is to the power 16 minus 1 times 1.05 minus 1. So this first term here, a, you can find by simply putting in the first one, which is 6 times 1.05. So this gives you 6.3, right? That's how you get A over here. And so once we have that, we can simply put this in our calculator to check what the value is. And what we should get in return is 173 minutes and 3 seconds. This is the time taken for her to complete the entirety of the race. So for this, the marks distribution is such that you get 1 mark for the correct summation here. And then you get another mark here for the correct sum of the correct sum of the geometric progression terms. And then using them together to get the total, another mark. And finally, your final correct answer gives you the 4th mark. So that's the end of question 11. So in question 12, we are given the function fx is equal to 10 e to the power minus 0.25x sine x. And in part A, we're supposed to show that the x-coordinates of the turning point of the curve with the equation y equal fx satisfy the equation tan x equal 4. All right, so for this, we need to differentiate our given expression here. So remember, fx is given to us as 10 e to the power minus 0.25x sine x. So here we have two different functions. Therefore, we need to apply chain rule. So when we apply chain rule here, we will get, so f dash x, right? So this will be, if I differentiate e to the power minus sine x first, we get negative 2.5 e to the power minus 0.25x. This will be sine x still. And in the second term here, if I differentiate sine x, it would be 10 e to the power minus 0.25x cos x. So these are the two terms I get when I differentiate my given function. Now, if I then equate this to 0, because remember, they're asking us to find the turning points of this curve. So we need to equate this because dy over dx, or rather your derivative, when your derivative is equal to 0, that's when you have your turning point. So 0 is equal to negative 2.5 e to the power minus 0.25x sine x plus 10 e to the power minus 0.25 x cos x, right? So here you can see e to the power minus 0.25x is there in both terms, so you can cancel it out. And once you rearrange your expression, you'll get sine x over cos x is equal to 10 divided by 2.5, which if you rearrange, you'll get tan x is equal to 4. And this is what the question asks you to prove. So for this, the marks distribution is the correct application of differentiation to get each separate term in your derivative gives you 1 mark each. And then equating it to 0 to find the turning points, another mark. And then finally showing your tan x is equal to 4 gives you the final mark. So that's the first part of this question, part A. Moving on to part B. Figure 3 shows a sketch of the part of the curve with the equation y equal fx. So this is the one they've given. And then sketch the graph of h against t where ht is equal to 10 e to the power minus 0.25 sine t, showing the long-term behavior of this curve. So you can see with this curve, right, we have an exponential and a sine graph. So from this, we can say it's going to be periodic in nature. But the thing with this exponential function is that your value would decrease the further it goes along the time axis. So therefore, and remember, this is the modulus function. Therefore, we can't have any negative values. So a function should be of the shape as such. Got my wrong there. Okay, so yeah, as you can see, with each decreasing with each increasing x value, our height decreases. And this is the shape we should get. So if you get the correct shape, that means it should be of the same shape like this. You get 1 mark for the shape. And the decreasing heights gives you the second mark. Right. Now on to part C. So the function ht is used to model the height in meters of a ball above the ground t seconds after it has been kicked. Using this model, find the maximum height of the ball above the ground between the first and second bounces. So for this, we know that between the first and second bounces, it obviously at the maximum point, it's going to have its dy over dx to be, or rather, in this case, your function derivative is equal to 0. So if we equate, if we solve tan x, the initial solution here, to find what are our x values. So if we solve tan x is equal to 4, we should get x is equal to 4.47 radians. Okay, so we can now substitute this into our ht equation. So h 4.47, right, is equal to modulus or absolute value of 10 e to the power minus 0.25 times 4.47, and then sine 4.47. Right. So if you calculate the value here, you should find it to be equal to 3.18, and this is your maximum height. So for this one, making sure you solve your previous derivative and finding the x value at the maximum point gives you 1 mark, and then substituting that into your height equation to get the height here gives you 1 mark. So that's part C. And finally, in part D, explain why this model should not be used to predict the time for each of bounds. So the thing about this is that if you look at it, with each bounce, right, the time between should not stay the same, because as you can see, with each bounce, the height decreases. That means the uh, time it takes between each bounce should be less. But in this case, since it's periodic in nature, that means that each of the bounces have the same time. Therefore, this is the reason why this model should not be used to predict the time of each bounce. So you can write this over here. The times between each bounce should not be the same when the heights of each bounce gets smaller. So this is the answer for part D. And if you get that right, you score the mark there. So that is the end of question 12 there. Now we'll move on to question 13. So in question 13, the curve C with equation y is equal to p minus 3x over 2x minus q times x plus 3, where p and q are constant, passes through the point 3 comma half and has two vertical asymptotes with equations x equal to and x equal minus 3. Explain why you can deduce that q is equal to 4. Well, this one's quite straightforward. So we know that asymptotes exist at x equal to and x equal minus 3. And if we put x equal to, we know that for an algebraic fraction like this, the two factors in the denominator are the equations of the asymptote. So therefore, if we put in 2 here, we'll get, so this is part 1 of part A. So 2x minus q equals 0 is our factor. Instead of x, we put 2. And so what we'll get is q is equal to 4. And similarly, for part 2 here, show that P is equal to 15. For this one, all you need to do is sub in your value of the point here. So substitute 3 comma half into your equation given here. So it should be equal to half is equal to P minus 9 over 6 minus 4 times 6. So this is basically when you put in 3.5 here. And so if you now rearrange this expression, you should get P minus 9 is equal to 6. And when you solve this for P, you should get P is equal to 15. So the marks distribution for part A is you get 1 mark for correctly attempting the first part. And then the use of substitution gets you another mark for the part 2. And then the correct value of P gets you the final mark. Moving on to part B here. So the figure 4 shows a sketch of part of the curve C. The region R shown shaded in figure 4 is bounded by the curve, the x-axis, and the line with equation x equal 3. Show that the exact value of the area of R is A ln 2 plus B ln 3, where A and B are rational constants to be found. Okay, so obviously in order to find the area, we need to first integrate the curve. And you can see from this equation, we'll need to first split this into partial fractions before we perform integration. So let's do that over here. So this is part B. So we have, once we substitute in our P and Q, we have 15 minus 3x over, this was 2x minus 4x plus 3. Right. So if we were to split this into partial fractions, it would be in this form, 2x minus 4 plus b over x plus 3. So if we now multiply both sides by the factors, we will get 15 minus 3x is equal to a times x plus 3 plus b times 2x minus 4. So if I now put in when x is equal to minus 3, right, I will be able to get rid of the constant a here. So it would be 15 plus 9 is equal to b times, this is now going to be minus 6 minus 4. So if you simplify this, you should get b is equal to negative 2.4. So that's the first constant. And then if you substitute in when x is equal to 2, you will get this to be 9, oh, sorry, this will be equal to 15 minus 6 is equal to, this side it's going to be a, this is now 3, so this will be 6a. Sorry, this will be now 2a, so it will be 5a, and this one will be 0. So then if you simplify, a is equal to 9 over 5, which is 1.8. So we found our constant values. You can now substitute them into your expression to get 15 minus 3x over 2x minus 4 x plus 3 is equal to 1.8 over 2x minus 4 minus 2.4 over x plus 3. This is now the partial fraction we need to integrate. Now, before we perform the integration, we need to know the boundaries here. So obviously we know one of the intervals is 3. We need to figure out this point here, which we can find as the intercept of the curve with the x-axis. So for this, we need to equate when y is equal to 0, right? Our equation would then simply be 15 minus 3x is equal to 0. So we have x equal 5. So we found our limits for the integration. So we can now write our integral as integration 5 to 3. So 5 is the upper limit, 3 is the lower limit. 1.8 over 2x minus 4 dx minus integration 5 to 3, 2.4 over x plus 3 dx. Right. So now let's do the integration here. So with this one, obviously 1.8 is the constant, so we can leave it as it is. The function 2x minus 4 becomes ln 2x minus 4, and you should also take into account the constant here of the function 2x minus 4. So divide by 2 ln 2x minus 4 minus, for this one we have 2.4 ln x plus 3. That doesn't change. Right, so then put in your limits. So once you substitute in your limits, you will get 0.9 ln 6 for the first one minus 2.4 ln 8 minus, so this is, let's say, the first substitution. Then when you put in 3 here, you should get 0.9 ln 2 minus 2.4 ln 6. Right. So if we now simplify, we have two ln 6 terms. So if you look at their coefficients, this is going to become plus 2.4. So we will have 3.3 ln 6 minus 7.2 ln. So here we need to first rewrite ln 8 here as a cube, right? So we can write it as 2.4 ln 2 cube ln 2 cube. And so this cube here can be written using the power rule as the coefficient, which we will go on to here next. So then this would be, the remaining term here would be 0.9 ln 2. Right, so we can simplify this to get 3.3 ln 6 minus 7.2 ln 2 minus 0.9 ln 2. So remember now in the original expression they have given in the question, we need to write it as a ln 2 plus b ln 3. So we have to now split ln 6 as ln 2 and ln 3. So that would be 3.3 ln 2 plus ln 3. This is using the product rule, minus 7.2 ln 2 minus 0.9 ln 2. So you can now simplify all of this, and your final answer here should be 3 ln 3 minus 4.8 ln 2. And therefore, you will get A is equal to minus 4.8, B is equal to 3.3. That is the answer for this particular question. So now let's move on to question 14. So the curve C in the standard Cartesian plane is defined by the equation x equal 4 sine 2y. The curve passes through the origin, and in part A, we are asked to find the value of dy over dx at the origin. So remember, x is equal to 4 sine 2y. So I can differentiate this respect to y to get dx over dy is equal to 8 cos 2y. So I can now flip this or take the inverse to get dy over dx. dy over dx is equal to 1 over 8 cos 2y. And remember, at the origin, the coordinates are 0, 0. So therefore, dy over dx is equal to 1 over 8 cos 0, which is equal to 1. Therefore, dy over dx at the origin is 1 over 8. So here you get marks. So I didn't go for the marking for the previous question. Let me go over that as well. So the breakdown of marks here for part B of this question here is you get 1 mark for attempting of partial fractions, and then getting the correct constant gives you another mark, and the correct expressions another mark, and then application of integration for each of the terms and getting them correctly for each of them, another mark, and then application of limits, another mark, and then use of logarithmic rules to simplify, another mark, and then finally your correct expression gives you the final mark. So in part A here, the marks distribution is attempting to find dx over dy and then rearranging it to get dy over dx, 1 mark, and then substituting in the value of the origin to get the final mark. Right, and then in part B, use the small angle approximation for sine 2y to find an equation linking x and y for points close to the origin. So here, instead of sine 2y, we can use the small angle approximation to write this as 2y, right? So then our expression will be x is equal to 4 times 2y, which would be x is equal to 8y, right? And therefore, so this is your answer. So you get 1 mark if you write this. And then in part 2, explain the relationship between the answers to A and BI. Okay, so here, obviously in part 1, right, what we got was the gradient of our function. And over here, it's the same thing. Now, if you look at this, right, if we write this in terms of y, we will have y equal 1 over 8x. And you can see they are the same coefficient. Therefore, you could say the value of dy over dx is the same as the dy over dx here. The value of dy is the gradient. You should mention that. I forgot to say that. Is the gradient of the is the same as the value of dy over dx is the same as the gradient of the line in part B 2. Oh, sorry, part BI. Okay, so you get 1 mark if you mention the correct comparison there. And then finally, in part C, show that for all points x and y lying on C, that dy over dx is equal to 1 over a square root b minus x squared. So for this, we would need to make use of a couple of trigonometric expressions. So we know x is equal to 4 sine 2y. So if you rearrange this, sine 2y is equal to x over 4. Similarly, dy over dx, we got as 1 over 8 sine, actually we can rather use dx over dy for simplification purposes. Dx over dy is equal to 1 over, 8 cos 2y. So therefore cos 2y is equal to 1 over 8 dx over dy. Right, so we can now use the trigonometric identity cos square y, or rather cos square 2y in this particular case. Cos square 2y plus sine square 2y is equal to 1. So you can now put these expressions into your identity. So you'll have 1 over 8 dx over dy square plus this is going to be x over 4 square equal to 1. Take the x term to the other side. You will have 1 over 8 dx over dy square is equal to 1 minus x over 4 square. You can now take the square root to get rid of it on this side and also multiply by 8 to get dx over dy is equal to 8 square root of 1 minus x over 4 square. Now, in order to match the form given in the question here, we need to do a bit of rearranging. So we will have dy over dx is equal to 1 over, so here if you take the 8, if you put in the 8 into your function, you will get this as 2 square root 16 minus x to the x square here. So by integrating 8 into your function, this is what you should get. And therefore, this will be your final answer. So the marks distribution for this part here, you get 1 mark for the correct manipulation of the variables, as well as the use of an identity to to substitute in those values, and then finally rearranging it to get your final expression gives you the final mark. So with that, we've come to the end of this paper. So once again, thanks for watching this video, and I hope that you found it useful in helping you practice this particular past paper.